Hey everybody, welcome back to section 2.2. And in this section, we're going to be looking at histograms, frequency polygons, and time series graphs. And we're going to figure out when is the best time to create each of these. So histograms are the first one, and hopefully you will watch the other video on how to make histograms on Google Sheets. And we've studied histograms before in Algebra 2 and some other classes. We have frequency, or relative frequency, going up the y-axis. And our x-axis are those individual bins. So to construct a histogram, we first decide how many bars or intervals we'll be using. And for that, it just depends totally on the spread of the data. So let's go ahead and look at some data. Here we have some data between 60 all the way out to 74. And they have it sorted in kind of the order of how each of these things are and how it's stacked together. You can see there's a lot of data here at the 66s and 66.5s. So where the stem plot would be nice, but there's a lot of data, so we don't necessarily want a stem plot. We're mainly looking between 60 and 74 for our data. So what we're going to be doing is thinking about what our boundaries could be. And so they're going to take a number a little bit below 60, 59.95. They're going to go every 2 units for the boundaries, and that will work it all the way up to 76 or 75.95. Then what we do is we take each of those boundaries and we find out how many pieces of data fit within that boundary. So here, 59.95 all the way to 61.95. That's going to be 0.05 or 5% of our data. And we could just use regular frequency to put however many data points we have in there, maybe like 4. But this one, they're looking at relative frequency, so that's a percentage. You can do it either way. Next one, there's 3% of our data that falls in here. You can see how the data is mostly clustered around the center between the 66 and 66.5 or between these two, but it was because it was 66 and 66.5. Okay. So here's some examples, and I have another video showing how to make these in Google Sheets, so I think I will not go through these examples here. The next one is called a frequency polygon. And frequency polygons are really similar to line graphs. They look a little bit different though, because we're going to have ranges here on our x values. We have a lower bound and an upper bound. And so this would be really work really well for a histogram. But if we don't want to make a histogram, we want to show what's happening as this goes on with a line graph in between. We can go ahead and graph that using a line graph, but since we have a lower and an upper bound, we need to find the midpoint between these two to use as our x value. So for 49.5 and 59.5, what we're going to do is take those two numbers and average them to get 54.5. That gives us this middle point here. The next one, 59.5 and 69.5, add those two together, divide by 2. We average them to get the 64.5. That's how we create this frequency polygon. Our final graph of this section is called a time series graph. And this is showing how things are changing over time. So here we have some data. We have annual consumer price index for months for 10 years. So what we're going to be doing is just taking each of these consumer price index values and graphing them as time goes on. And we're going to graph out each month. And you can see this is slowly increasing up, looks like on a linear level. So it's really helpful to see how things are changing over time. Really straightforward. We've seen a lot of graphs like this before. And here's an example of something you could do, 3 different countries and their CO2 emissions. And there's an example of how to do this in Google Sheets as well. All right.